So at this point, you should see now the oil palm application. Like I said, the user is provided here with a predefined workflow. And this is not flexible. You can't add or move the various elements of this workflow around. The user works through the workflow here from top to bottom, always top to bottom. And the first step, of course, is to import data. You can see which one of these actions you are currently in. It's highlighted here, and it's not possible to skip an action and go to a next one. You should be prompted with an error message. So the first thing we need to do is import our data for the analysis. In this case, I need an ortho photograph, and I can select one, and you also need at least a digital surface model to conduct any of the analysis within the oil palm application. At this point, I do want to mention the data requirements. It's very specific for the oil palm application. An ortho-rectified image with 3 bands, or at least 3 bands, and a ground sample distance of 10 centimeters or less is required. And the 3 bands have to be either red, green, blue, or you can combine it also with the near-infrared. And you also require at least a digital surface model, so that DSM has to be provided, and that DSM should also have a ground sample distance of 30 centimeters or less. So you cannot use a DSM derived from, say, the SRTM data set in the palm oil application. We require a very high resolution DSM product. We recommend that the user also import a DTM, so their digital terrain model, again, with this GSD of 30 centimeters or less. But like I said, it is possible, like we'll see here in this example, to use the minimum requirements of an orthophoto and a DSM. So once I complete a task here, I get the checkbox and I can see my data is available and move on to the next task, which is then defining the setting, and then we're just asking what is the camera type, and this is an RGB camera, and then you can actually define the project units here, and then just confirm with OK. And this is where the user can then define or load these so-called blocks. So the palm oil plantations are often divided into blocks, and the user can either create these blocks themselves here in the manual creation. So you'll find all tasks that are related to an action are then appear down here, and again, stepping through from top to bottom. So the user can either create the blocks manually or import them from a shapefile, or simply just use the entire image. It depends on what their data availability is and what you want to use here. So I'll just create some demonstrative blocks. It is possible to have, of course, more than one block to use. Something like this. And then I'll just take a small section over here. And then I will save these blocks. Once the blocks are saved, we just reduce the area that the software is looking at to those extents. Next, the user has the choice of whether they want to generate what we're calling an estimated DTM layer. So if they did not have the DTM as an input, they may want to consider doing this. Again, it's an optional step that can lead to some improvements in the analysis. So by default, it's set to no, and the user can say, yes, I do want to estimate the DTM, and then they have some options based on what type of environment they're working in, whether it's flat, very flat, or rough and hilly. So I will choose very flat here. And now eCognition will, based on various input parameters, estimate the DTM and generate a estimated digital terrain model based on this. You are told that it is finished. When it's finished, part of this calculation is also generating what is called an NDSM, so it's a normalized differential or a normalized digital surface model. And this is what that surface model then looks like. What we're seeing here are then the objects, their height relative to ground, so their absolute heights here. And again, I can also come in, that would be been the DTM that was calculated, and then here to get back to that initial DSM that was used. And then if I want to look at my true color image, I can choose to do so as well. And always finishing with save, and once that little check mark appears, you can move on to then the next task. In this case, now we are going to detect and analyze the palms, and the user has to set some parameters here. You have the option of defining various sizes here, whether you want to look for small palms. The default will say not present in the image, but I do know here, if I zoom in, I see I have some very small palms in between the larger rows. So I will say yes, I want to detect these smaller palms, and I'll continue to, I'll say, to use the default settings here for the medium and large palms. You also have the option of whether you want to detect the anomalies or not. By default, we leave that on, so that will analyze whether a tree is healthy or not, and the user can then adjust this anomaly index based on the parameters, conditions of their imagery to find more or fewer of these palm trees. And that's based on various parameters within the imagery, not just, say, an NDVI, but other brightness criteria within imagery. That's why the user can use this slider to adjust here. I'm just going to leave the default values at the moment. Once all the parameters are set, you can then hit the Detect Palms button, and now the software will automatically go through and generate essentially a point file at the center of each, or roughly at the center of each palm tree. And in this case, we're also calculating an approximate crown size and looking at a tree's sickness or tree health. And based on the area that is being analyzed, it can take longer or less time. So I can see the results look fairly good, but there are some errors contained. That's not too much of an issue. We can come in and save these initial results, and as you can see, the next task is here, Edit Results. So I can come in and zoom in. I see I missed a few of these small palms here. The imagery is very washed out in this area, so it reflects some of the quality of that estimated DTM that was generated. So I can come in and add and remove a tree here. Notice that when I add the tree, it is automatically calculating whether it's going to be small, medium, or large. That's here on this auto setting that can be used, or whether it's healthy or unhealthy. Now you can also edit the size of a tree. It's very simple. I can click once to grow or shrink these crowns. And once the user is then happy with the classification, I see here, for example, I have a point that was out on the road. I can remove that as well. You can come in and then save your results. You can also adjust the color displays here. So I can look at the anomaly. Maybe I want to assign this some type of a red fill. So these are the unhealthy trees. And you can see how those correspond to these brighter canopy. So that's the brightness of the canopy is an indication of whether this tree is healthy or unhealthy. And these can just be used for visualization. So I'm not going to spend too much time editing. Obviously, the more you want to edit, the more a user can. Typically, if you find yourself editing a lot, it's probably a good indication that some of your initial data was not of great quality here. Particularly in this case, some of these smaller palms, they just did not show up in that estimated DTM that I had. If I had a real high quality DTM that I used derived from a product like Info or UAS Master, that could definitely improve this analysis. That's why we say that the use of DTM is recommended here, but it is not required. So I'll save my results now. And now I come down to the export section, and you see a number of options are available. I can simply export the center of the tree, so a point file representing the center of my trees. I can also choose to export a shapefile for the tree crowns and the blocks. So if I define these blocks myself, I can also export those to a shapefile for future use, for example. What is included in this shapefile? You also can open up the attribute table to see what is going to be exported. So right now I'm looking at the tree file. So this would be the individual points, and I can see what block the tree is within. There is a tree ID that is automatically generated, whether the tree reflects an unhealthy tree, so it's an anomaly, that would be an unhealthy tree or not. You can also get the crown size. There is the tree density is here, as well as in the XY centers. You have the tree elevation, so we're reading that elevation of the tree from the DSM. If you have a DTM, then we can also calculate the physical tree height. And then finally, I'll just have to expand the menu here. We have this comment field, and this is very nice. We can see with what method the palm was identified. So you can see here it says template matching. So we're using some template matching technology behind the scenes to identify these palm trees. But it goes beyond just a simple template matching procedure. You can also see that there's another approach, this by elevation difference. And finally, if you actually manually added a tree here, you can see what trees then were created manually based on their attributes. And all these statistics are then exported, of course, with that shapefile. And you have also here, just for the tree anomalies, this would be done in the tree crowns. You can just look at the sick trees, or I can just look at my healthy trees here. And then also by block, you can export the statistics by block to see physically how many palms are located within each block, and various block-related statistics. In addition, once we actually run the analysis, you also have a density map that is created. So if I turn off my vector layers, we can see this better. And we're just looking here, generating this view of the blocks based on tree density, and this can give the plantation owner or operator an indication of where the planting is thinner or thicker, and maybe that correlates with tree health or various other statistics, things that they're looking for. And they may need an indication of, here I need to do some thinning, or maybe here I can afford to plant more trees within this location. In addition, the user can export a PDF report, and that will give them various statistics in a nice PDF format that they can turn around and provide to somebody. But this is the functionality of the oil palm application. As you can see, it's very straightforward, simple to use. In my mind, it can actually be enjoyable to use for someone. They don't require a very technical understanding of, say, remote sensing or GIS. We would hope that they would know what a palm tree is as opposed to some of this vegetation here. Maybe this is acacia or something, and also how some of these palms are detected, you know, what they look like in an elevation model versus the imagery itself. But that's why we also provide these different views here, so they can see that this tree was actually it's there, but it wasn't a strong enough elevation signal to initially get picked up. They can also switch between these view modes to go back and edit the results. And there's really no place for the user to get lost in this whole process. They have to work, again, from top to bottom. They're going to be given an error message if they try to skip a step here in the process. So they won't be able to jump from the defined project settings to detecting the palms. They would have to go back and define their blocks and the fact whether if they want to use a DTM or not here. So that's the oil palm application. And if you have any questions, feel free to let me know, and either now or via email later. And I would also recommend contacting, I believe, John Whitehead from, I want to say he was involved in some of the email train here. I know they've done some other studies based on that in the APAC region. Or Teresa Hong, I know she's been responsible for sales, at least in the APAC region here, so she can also talk to other aspects of the software.
Thank you very much, Keith. This is very helpful. We are going to go ahead and translate everything. Could you please do a favor and send us just the PowerPoint presentation, because your demonstration we recorded.
Okay. Okay. So you just sure. I can send you that. I would ask that it not be distributed to users themselves. It's a demonstration that comes from our product management just for a product overview. But I'd be glad to send it to you. I can put it into a PDF and send you those slides. Just let me make a note of that. Okay. It's important to note, though, when you're actually talking to the end customer here, that they are aware of the data requirements. So, and that is stated. This is in the user guide to the software, which is available when you download the software. I believe it's also stated in the text sheet that went out with this software, is that these requirements are very crucial, and I say this because we've had customers come from the Southeast Asian markets and contact us with that they're having problems using the software, and it turns out that they're using data sets that do not meet these data requirements. So that is one thing, to make sure that they are using UAS data. And again, the package was specifically designed to harmonize with the UX5 HP, but other UAS products are obviously supported. Just note that optimal results are going to be from say the UX5 HP in combination with products coming out of the TBC package or a UAS master package.
Yeah, okay, thank you.
No problem.
So, thank you very much for your time and for the presentation. And hope to have a real opportunity here with this company, and we repeat with other in Brazil. Thank you.
Okay, excellent. Then have a good day, and if you have any other questions that come up after your meeting, then feel free to email myself or someone else from the Munich team. We can answer those.
Okay, take care.
Okay, take care. Bye-bye.
Thank you, bye.